Hello, good day. I hope you are doing great by God's grace. Today we are going to look at Introduction to Periodic Chemistry. Okay, that is what we are going to look at for today. Introduction to Periodic Chemistry. So, what then is periodic chemistry? So basically, periodic chemistry refers to the analysis of how properties of elements, whether these properties are physical properties or chemical properties, how these properties vary with their electron configurations. So looking at all these elements, let's take the first 20 elements into consideration. You know that they all have their various electron configurations. I don't know if you remember, if you're asked to write the electron configuration for potassium, you write 2, 8, and what? Another 8, and then 1. I don't know if you remember that. Okay, so we are just going to look at our periodic table, and then all that we are going to do is just some analysis. We are just going to analyze how physical properties and chemical properties vary with changes in the electron configuration. So we'll study as we go on, you get the whole concept better. Okay, that is basically what periodic chemistry is about. Analyzing how physical and chemical properties vary, the variation, the changes. You get it? There are some points that they are similar, and there are other points that they are entirely different. Okay, so it's just analytical work we are going to do. So, you know of atomic number. What is atomic number? Atomic number is basically the number of protons in the nucleus of an atom. Okay, and then if the atom is a neutral atom, then it means that the number of protons will be the same as what? The number of electrons. Okay, as we move on, the whole concept will be clearer. Okay, so we know atomic number is represented by Z, number of protons in the nucleus. In the nucleus, what other subatomic particle do we have? You know that it is what? The neutrons. Okay, so the protons and the neutrons come together to form what? The nucleus. Or when we are talking about the entities, then those ones will be what? Nucleon. Okay, though there are some other subatomic particles that are there, but then we don't really focus on them. You'll be focusing on them in physics. Okay, we have quarks and leptons. Okay, but since that is not our focus, we know that the subatomic particles that are in the nucleus are what? Neutrons and protons. Okay, and the subatomic particle that is on the shells. Okay, that is what? The electron. Okay, now we know mass number. What is the mass number? Mass number is basically the sum of protons and neutrons. Okay, so you know that the nucleus of the atom is the heaviest aspect of the atom, right? And then the shell and the electrons are very light. And remembering from the J.J. Thomson's and Rutherford's, I think this is basically based on Rutherford's model. Okay, so I don't know if you don't remember, then kindly remind yourself of the Rutherford's model of the atom. You can realize that the whole mass of the atom is almost at the center of the atom. Okay, that is why that area is called what? The mass number, because the nucleus is what is made up of the protons and the neutrons. So when you add the mass of the protons and the mass of the neutrons together, you get what? The nuclear number, which is the same as what? The mass number. Okay, nuclear number is basically another name that we give to what? The mass number. Now you can see this beautiful diagram on your screen. So these are the first 20 elements. Okay, I think you can see my pointer there. So hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, you can see them. So you just analyze them. And I've given you this is a very simple periodic table because as we move on, you get the complex ones. Okay, so I'll be referring to this periodic table as and when it's necessary. Okay, and this is the complex electron there's a complex periodic table. That's actually the periodic table you are supposed to know. Okay, and based on your level currently, this is the periodic table you are supposed to know, not this one. No, this one is for JHS people. This is a KG2 periodic table. Okay, so kindly make yourself abreast with this periodic table rather. Okay, so we move on. Arrangement of electrons in the shells. Okay, now we know that electrons in an atom, where do they live? Electrons live on the shells. Okay, where do protons live? In the nucleus. Where do neutrons live? In the nucleus. But where do electrons live? They live on the shells. Okay, and actually there are 7 shells that are available. Okay, so we have the K shell, the L shell, the M shell, the N shell, O, P, and Q. So you know that K, I, J, K, L, M, N, O, P, Q. Okay, so there are 7. Okay, 7 of the shells we have. Now, what then is a shell? A shell is basically a volume of space around the nucleus where there is a high probability of locating an electron. I think this definition is quite close to that of an orbital. Okay, but look at that of an orbital, you realize there is a little bit of difference. Okay, so the space around the nucleus where there's a high tendency of what? Locating an electron. Okay, now what is next? Electrons on different shells possess different energy levels. Let me see if I can help you with a diagram. Good. So you can see this diagram on your right here. This is the nucleus. The first shell is the K shell. The second one is the L. Next one M. Next one N. You get it? So this K shell, since it's very close to the nucleus, it has a very low energy. Okay, followed by L, followed by M, followed by N. So when I ask you, compare the energy levels that exist between K and N, you should be able to tell me that K has a lower energy level as compared to what? The N shell. I don't know whether you are getting it. I believe this is very clear. I believe this is making sense. Okay, so the closer the shell is to the nucleus, the less its energy level. So when I say K and M, you can tell me that the M shell has more energy or it has a higher energy level than the K shell. Okay, all right. So that's what I just explained, that electrons on different shells possess different energies. Now, okay, so example, since the K shell is closest to the nucleus, we have explained that there is a formula. The maximum number of electrons a shell can hold is expressed as what? 2n squared, where the n is the principal quantum number. Okay, you'll be learning about quantum numbers, I believe, in physics, yes. Okay, so where n is actually the shell. Okay, so K shell has a principal quantum number of 1, L is 2, M is 3, N is 4, O is 5, in that order. You get it? So let's write the formula and then put up do some work examples. So um, we are saying that um, let's get okay. So we are saying that the formula is what? 2n squared. Okay, with this 2n squared, we are looking at the maximum number of electrons that the K shell can carry. We know that K is what? 1. K is 1. L is 2. M is 3. N is what? 4. Okay, so let's solve for the first one. So 2 into bracket 1 all over what? 2. No, to the power 2. So we know that 1 squared is what? Is still 1. 1 times 2. 1 times 2, that is 2. We'll open this bracket and give you what? It's going to give us 2. Okay, so that's the first thing. So it means that, no, sorry. So it means that when n is 1, this is 2, so I can put down the answer. So this answer is 2. It means that the K shell can take a maximum of 2 electrons. Now when L is 2, or on the L shell, so we know that 2 to the power 2 is what? 4. Okay, so we are getting 2 into bracket 4, and that is giving us 8. It means that the L shell can take a maximum of 8. Now let's look at another one. 2 into bracket 3 squared. We know that 3 is 9. That is the 3 squared. So 9. And then 2 into bracket 9. 9 2 is what? 18. Then it means that the N shell can take a maximum of 18. And then this is 4, right? So 2 into bracket 4 all squared. We know that 4 is 16. Okay, so 4 is 16. So 16 into bracket 2, meaning that we are getting what? 32. Sorry for the mistake here. So that's 32. It means that K shell takes to L8, M 18, and then N 32. Let's look here. Well, let's continue. So we can see that that is what we have here. Okay, it's basically that we have here. Just that there are certain instances where instead of the M shell taking 18, it rather takes 8. And then the N shell also takes 8. Okay, this is due to a rule called the octet rule. Okay, but the maximum number of electrons that the M shell can take is 18. And then the N shell can take what? 32. So you can calculate that for the Q shell. Okay, that will be 7749. 49 times 2. You should know your answer. Okay, so that's very simple. So these are the maximum number of electrons that each shell can take. Just that there are certain conditions in which the M shell, the N shell, and the rest are allowed to take only 8. And that's what the octet rule. Apart from those conditions, the maximum 18, 32, and then the rest. So what then is electron configuration? You've been solving questions on electron configurations, especially in SHS. Okay, they tell you to write the electron configuration of sodium. Okay, and then you write it. So electron configuration basically talks about what? The distribution of electrons in an atom. So how the electrons are, the electrons are not haphazardly found on the shells. Okay, they are arranged. Okay, you don't have just one shell that all the electrons are found on. No, the electrons are well arranged. So the way they are arranged, or the way they are distributed on the shells, is what we call what? Electron configuration. Now, there are basically two groups of electrons. We have what? the core electrons and the valence electrons. Okay, so let's take an example here right now, and then so let's go down. Let's go. Let's go down here. Okay, just a minute. Okay, so if we have, let's say, sodium with atomic number, what's 11, right? Good. So if we are drawing, we know that, let's say this is the nucleus. Let's say there's a nucleus. No, let's ignore the nucleus for now. We know that the nucleus is inside. And then there's a first shell, second shell. Before we even draw the shell, we know that in electron configuration, when we're in JHS, when you're asked to write electron configuration, you know that the K shell will take what? 2. So that's 2. The L shell will take 8. Okay. And then the M shell will take 1. Why? Because the number of electrons, we know that sodium is neutral because this is not sodium plus or this is not sodium minus. Um, Immediately becomes an ion that is plus or minus. That is when we know that it's no more neutral. But since we were given just sodium, it means that the sodium is neutral. Okay, so it has how many number of protons? You know there's the atomic number, same as proton number. So it means it has 11 protons. And the number of protons is the same as the number of neutrons inside what? Inside a, a neutral atom. Okay, so we have 2 here, 8 here, 1. Because the K shell would take 2, L shell can take 8, N shell, M shell is going to take 1 because we have only 11 electrons. So 2 plus 8 is 10. So the next one, you know that the M shell could have taken 8 electrons, but we have just 1 electron left. That's why we just gave the 1 to it. So if we are representing it on the shell, so there's the first electron on the K shell. So there's the K shell with 2 electrons. L shell would take 8 of them, so 2 here, 2 there, 2 down here, 2 on the left. Okay, we know that there are 3 shells, right? So K, L, M, this is the M shell. The M shell is going to take only 1. Okay, so there are 2 types of shells. The outermost shell, you know that this is the outermost shell. This outermost shell is called the valence shell. Valence. Okay, this shell is called the valence shell. So the electron found on this shell is called the valence electron. And then these shells, the shells that are not the valence shell, they are called the core shells. Okay, so core shells like core mat. Okay, that is inside. Okay, those are the core shells. And even this one is also a core shell. So the shells that are in between the nucleus, we know the nucleus is here. The shells that are in between the nucleus and the valence shell is what we call what? The core shells. Okay, so electrons found on core shells are called what? Core electrons. Okay, now let's look at a property of the core electrons. Very important. Okay, let's look at a property of the core electrons. So we realize that electrons in the outermost shells are called valence electrons, I've told you. And then valence electrons are actually the electrons that are responsible for chemical properties. Core shells are not the ones responsible. So it's valence electrons, the electrons that are in the outermost region. Okay, electrons that are in the outermost shells, they are actually the ones that are responsible for what? The chemical properties of the element. Okay, but not the core shells. Okay, so you can see that core electrons do not participate in what? Chemical reactions. Okay, so take note. These ones do not partake in chemical reactions. Okay, so we move on. Now we are going to an important aspect called the periodic law. Okay, so this law states that properties of elements depend on their respective atomic numbers. Okay, so it means that um, the physical property of a certain element is based on its atomic number. Okay, so um, aluminium may have a different atomic property, let's say a different melting point from, let's say, oxygen, because they have different atomic numbers. Okay, so the properties that a specific element is going to exhibit depends on the element's what atomic number. That is basically what the periodic law is saying. Okay, so the periodic law gave birth to periodic table. Okay, and periodic table was brought up by one Russian chemist, Dmitry Mendeleev. Okay, he brought about the modern periodic table. Okay, so periodic table, what then is a periodic table? Because you've been hearing of the periodic table since JHS. What is it? It's basically a table that shows all the elements arranged systematically in order of increasing atomic number such that their outer electron configuration and properties reoccur at regular intervals. So, so these elements have been carefully arranged, okay, in order of increasing atomic number. And through the careful arrangements, they realize that some of these properties they reoccur, okay, in certain groups and periods. We'll be getting to groups and periods very soon, okay, and you understand the concept better when we move on, okay. So their properties reoccur at regular intervals. Now, what then is a group? Okay, so elements with the same number of valence electrons in the outermost shells make up a group. Okay, and the groups are named based on their number of electrons. Okay, and so we have group 1, group 2, group 3, group 4, group 5, group 6, group 7, and then group 8. Another name for group 8 is what? Group 0. Okay, and these ones have what? Um, Common names of family names. Okay, um, so the name is actually based on what? The group name is based on what? The number of valence electrons. So group ones have what? One valence electron. Group two have um, two valence electrons. Group three valence electrons. Please take note of the fact that group eight have eight valence electrons. Okay, they have eight valence electrons. And so group ones are also called what? Alkali metals. So in an exam, if you don't see group one and you see alkali metals, you should know what they are. Group two are called alkaline earth metals. Group sevens are called halogens. Halogens are, I think it's from Latin, me, and it means salt formers. Later you realize that it's these elements that combine to form salts. Okay, and we have inert gases or rare gases or noble gases. You get it? And they are also called group zero elements. So these ones, group eight members, they don't react. Okay, they are non-reactive. So as time goes on, you get to realize that. So let me paint a better picture of what I was saying. So this is what you know already. This is a periodic table that you are aware of. So you can see that this is group 1 running from top to down. hydrogen, lithium, sodium, potassium, that's group 1. Beryllium, magnesium, calcium, that's group 2. Boron, aluminum, that's group 3. Carbon, silicon, that's group 4. It means they have 4 valence electrons. Nitrogen, phosphorus, that's group 5 because they have what, 5 valence electrons. Oxygen, sulfur, group 6 because they have 6 valence electrons. And then helium, neon, argon, they have what, 8 valence electrons, so we call them what, group 8. Okay, how did we get to know the number of valence electrons? It's very simple. Let's take boron and aluminium. Okay, let's consider boron and aluminium. We know that boron has what, an atomic number of 5. Aluminium has an atomic number of 13. So let's go back to our sketch pad and then we sketch down something. So, so we know that boron, that is B, has an atomic number of 5. Aluminium has an atomic number of what, 13. Okay, so when we are even writing the electron configuration, you realize that it's what, 2, 3. Is that not it? Yes. And then here with the aluminium is what? 2, 8. Okay. And then 3. Is that not it? So we realize that this one has 2 shells. This is the K shell, L shell. And then this one has what? 3 shells. This is K, that is L, that is M. Okay. Now let's look at the valence electrons. This has 3 valence electrons. That also has 3 valence electrons. It means that they are in group what? They are in group 3. You get it? If you want us to represent it on the shells, it's going to be like this: 2 here, and then 1, 2, 3 there. You get it? So in the valence electron, you know that valence electron is the outermost shell. Okay, so the valence electrons are 3. Now let's look at the aluminium too. This is one. Oh, sorry. This is one electron. That is another electron. We are going to the next shell. This is one, two, three, four. Good. And then the next shell again, because the L shell can take a maximum of 8. And then that is that. Okay, so this is for aluminium, that is for boron, and you realize that the outermost shell for aluminium still has 3 electrons. So it means that aluminium and boron, though they have different number of shells, aluminium has 3 different shells, and boron has only 2 shells, and they still have the same number of electrons in their valence electrons, and so or in their valence shell, and so they are all group 3 elements. Okay, so that's that. That is that for groups. Okay, so we say that elements that have the same number of electrons in their outermost shell make up a group, and you know the other names or family names of the various groups. Okay, so you can prove that aluminium and which other metal, um, aluminium and calcium are all in the same group. How do you prove it? You should be able to prove it by being able to write down the number of electrons in the valence shell of each atom. Okay, now let's look at what a period is. Okay, so a period basically refers to elements that have the same number of shells. Okay, so elements that have the same number of shells are said to be in the same period. So an example is what sodium and silicon, we say that they are all in the same group. I'm going to prove that to you. Elements in a group are arranged in a vertical column of the periodic table, whilst elements in a period are arranged in a horizontal column. So you can see that this is actually a group. So group 1, group 2, group 3, you know that they have been arranged vertically. And then this is period 1, that is period 2, this is period 3. So they've been arranged what? In a horizontal fashion. Okay, so I mentioned the fact that silicon and what? I think silicon and aluminum, let me check again, and then sodium and silicon, thank you. I mentioned that sodium and silicon have the same period, or they are in the same period, and that's true because they have the same number of shells. Okay, so how do we do that? Sodium has atomic number of 11, silicon has atomic number of 14. So let's go and draw them. Okay, so 11 and 14, and you realize they have the same number of shells. Okay, since they have the same number of shells, we say that they are all in the same group. Okay, so um, sodium is 11, and then silicon, I think silicon is 14. Okay, good. This one we are not going to draw the shells. We know that this is going to be 281. This is going to be 284. How many shells? This is K, L, M, so three shells. K, L, M, so three shells, and it means that they are all in the same period. So that is basically about the periodic properties, and this is just an introduction. Okay, and as time goes on, you get things to be very clear. Okay, so I hope you enjoyed this part of the video. As time goes on, we'll do more things and you realize how easy this topic is. So thank you for following this video and I'll see you in the next video. Bye.